is the importance of criminal investigation. Criminal investigation is vital for upholding justice and maintaining societal order. Firstly, it holds perpetrators accountable for their actions, providing closure to victims and their families. Secondly, it ensures public safety by apprehending criminals and preventing further offenses. Thirdly, it acts as a deterrent against future behavior by showcasing the consequences of unlawful acts. Moreover, criminal investigations facilitate the collection and preservation of evidence, essential for building strong legal cases. They also uncover the truth surrounding criminal incidents, promoting transparency within the justice. Furthermore, investigations support prosecution efforts by supplying crucial evidence and information for trials. Lastly, they contribute to the exoneration of wrongfully accused individuals, rectifying miscarriage of justice. Overall, criminal investigation serves as cornerstone of law enforcement, safeguarding communities and upholding the principles of fairness and accountability within society. Criminal investigation, it is the collection of facts in order to accomplish the threefold aims: to identify the guilty party, to locate the guilty party, and to provide the evidence of the suspect's guilt. In retrieving a criminal investigation, establishing the six cardinal points is necessary in the investigation, namely, what specific offense has been committed, how the offense has been committed, who committed it, where the offense was committed, when it was committed, and why it was committed. In such investigation, forensic chemistry plays an important role in determining the relationship of any evidence found in the scene.
The basic principles of forensic chemistry. Number 1. Locard's exchange principles. This principle states that every contact leaves a trace. In the context of forensic chemistry, it means that when two objects come into contact, there is always a transfer of material which can be used as evidence. Locard's exchange principle is applied in forensic chemistry by analyzing trace evidence left at crime scene. This could include fibers from clothing, hair, skin, cells, or residues from substance. Forensic chemists analyze these materials to establish connections between suspects, victims, and crime scene, helping to reconstruct the events that took place. Number 2. The principle of individuality. This principle states that every material, whether it is a chemical substance or a physical object, is unique and can be distinguished from all other materials. The principle of individuality is a significant in forensic analysis because it allows forensic chemists to identify and differentiate between substances based on their unique properties. This can be crucial in cases where the composition of substance, such as a drug or a poison, needs to be precisely determined to link it to a suspect or to understand its effect on the victim. Number 3. The principle of conservation of mass. This principle states that mass is neither created nor destroyed in a chemical reaction. In forensic chemistry, this principle is used to analyze and interpret the results of chemical reaction. The principle of conservation of mass is utilized in forensic cases by ensuring that the mass of substances before and after a chemical reaction is accounted for. This principle is particularly important in cases involving arson or explosives, where the analysis of residues can reveal the materials used and potentially link them to a suspect through purchase records or possession of similar materials. The principle of definite proportion. This principle states that a chemical compound always contains exactly the same proportion of elements by mass. The principle of definite proportion plays a role in identifying substances by ensuring that a chemical compound is composed of the same element in the same proportion by mass, regardless of its source or how it was prepared. This allows forensic chemists to compare samples from a crime scene with known substances to identify them accurately. Number 5. The principle of multiple proportion. This principle states that when two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other elements are in a ratio of small whole numbers. The principle of multiple proportions is used in distinguishing between explosive materials by analyzing the ratios of elements that form different explosives. For instance, the ratio of nitrogen to oxygen in various nitrates or nitrates can help identify the specific type of explosive materials. This principle allows forensic chemists to differentiate between substances that may appear similar but have different explosives.
Scientific evidence applications. Forensic chemistry plays a crucial role in the analysis of scientific evidence within the criminal justice system. Here are some key applications. First is document analysis, which determines the authenticity of documents or detecting alterations or forgeries. Second is explosive analysis, which examines residues to identify the type of explosives used in a crime. Third is fingerprint analysis, where chemical methods are used to recover latent fingerprints from various surfaces. Fourth is fire debris analysis, which identify and compare samples of fire debris to determine the cause of fire. Fifth is illicit drug analysis, where forensic chemists analyze substances to determine if they are illegal drugs. Sixth is toxicology, testing biological samples for toxins, drugs, or alcohol to understand their impact on individuals involved in criminal cases. Last is trace evidence, analyzing small quantities of materials like fibers, glass, paint to connect a suspect to a crime scene. These applications demonstrate the intersection of chemistry and law enforcement that can link evidence to suspects and crime scenes. Scientific evidence applications. Forensic chemistry plays a crucial role in the analysis of scientific evidence within the criminal justice system. Here are some key applications. First is document analysis, which determines the authenticity of documents or detecting alterations or forgeries. Second is explosive analysis, which examines residues to identify the type of explosives used in a crime. Third is fingerprint analysis, where chemical methods are used to recover latent fingerprints from various surfaces. Fourth is fire debris analysis, which identify and compare samples of fire debris to determine the cause of fire. Fifth is illicit drug analysis, where forensic chemists analyze substances to determine if they are illegal drugs. Sixth is toxicology, testing biological samples for toxins, drugs, or alcohol to understand their impact on individuals involved in criminal cases. Last is trace evidence, analyzing small quantities of materials like fibers, glass, paint to connect a suspect to a crime scene. These applications demonstrate the intersection of chemistry and law enforcement that can link evidence to suspects and crime scenes.
What is the physical evidence? The Locard change principle explained that a preparatory always leave evidence behind because of the object or people they came in the contact with, or the object they have taken from the crime scene. Different types of physical evidence. Criminal shape and size and can be either considered corroborative evidence by supporting a theory or circumstantial evidence by indirectly inferring a conclusion to the crime. Lockhart change principles state that every contact leave a trace. This means that when a crime is committed, that preparatory will leave behind evidence, and they will also take something from the crime scene. These different types of physical evidence. It requires two virus collection techniques to avoid communication and damage. Paint. The chemical and physical analysis of type of paint can be used to match evidence to a suspect by examining characteristics such as color, number of layers, etc. Glass. Tint, color, chemicals, composition, density, and other properties of glass can be examined of particles found at the biopsy crime scene, such as hit and run, murder, breaking, and entracing. Explosive. By using chemicals analysis and tracing the materials of explosive can lead to a suspect work home, lead to another connections. Ballistics. Analysis of the characteristics of firearms, gunshot residue, ammunitions help investigator find match between the evidence found at the crime scene and the suspect. Dust and dirt. Dust, dirt, pollen, plants, and more left at the crime scene can be used to determine where a suspect has traveled from. Impression evidence. There are three types of impression evidence: shoe prints, anterior tracks, bite marks, and tool marks. Each of these can use to either one or combinations of the following collection tactics, such as the photographs, lifting the tape, or casting with a plaster. When the property tactics are used, to impression evidence can help investigator match to other items or the suspects. Fingerprints. Investigators will use the automated fingerprints identification system to analyze between the three types of fingerprints to find a match. Question documents. These documents includes the ransom notes, letter, water remarks, and more, all of which can provide useful clues, DNA, body fluids, hair, etc. All of this can provide information about a crime and be tested from matches of other samples.
Retrieval procedures for criminal investigations. First is identify the type of investigation you are conducting. Determine the specific information you need to retrieve in investigating. Determine the jurisdiction where the crime scene occurred and research the local law enforcement agency responsible for the type of crime in the identified jurisdiction. Number 1. Crime reporting. The first step is any criminal investigations is the reporting of the crime. This can be done by a victim, a witness, or any other person who has knowledge of the crime. Contact the identified law enforcement agency to report the crime. This can usually be done by calling the non-emergency number for agency. Provide the law enforcement agency with the relevant information about the crime, including the date, time, location, and any details about the perpetrator or other involved parties. Follow up with the law enforcement agency to ensure that the crime has been properly reported and provide any additional information that may be requested. Number 2. Initial response. Once a crime reported, law enforcement officer respond to the scene. They secure the area to ensure evidence is not disturbed and gather preliminary information. Secure the crime scene to prevent contamination or tampering. The crime scene is secured by setting up physical barriers, hosting guards, and limiting access to authorized personnel only. Conduct a preliminary survey of the scene. The preliminary survey includes noting the general layout of the scene, identifying potential evidence, and determining the type of the crime that has been committed. Documents the scene. The scene is documented by taking photographs, making sketches, and writing detailed notes. Collect initial evidence. Initial evidence could include fingerprints, blood sample, DNA samples, or any other physical evidence that is immediately apparent. Interview witnesses. Witnesses are interviewed to gather information about the crime, the suspect, and the initial findings. Secure the scene for further information. The scene is secured by leaving it undisturbed, ensuring that all evidence is properly collected and stored. Crime scene investigation. Crime scene investigation come to the scenes to collect evidence. This might include photographs, fingerprints, DNA sample, other physical evidence that might help solve the crime. Follow-up investigation. Investigators follow up on leads generated by the evidence collected at this scene. This might involve interviewing witnesses, checking surveillance footage, and other investigative activities. Case review. The case is reviewed by a prosecutor who decides whether there is enough evidence to charge someone with the crime. If there is, the case goes to court. Court proceedings. The accused person goes to trial, where all the evidence is presented. If they are found guilty, they are sentenced. Post-conviction review. After conviction, there may be a review or appeal process. This is where the case is looked at again to ensure that everything was done correctly and fairly. These procedures are crucial and ensuring the integrity of the investigation and the evidence collected. They help move a case from suspicion to reasonable grounds for belief and ultimately to a court decision.
In concert, these components form a comprehensive framework for conducting effective criminal investigations. By integrating basic forensic chemistry principles with cutting-edge scientific evidence applications, investigators can uncover hidden truths and unravel the complexities of criminal activities. The diverse array of physical evidence types encountered in forensic investigations provides multiple avenues for corroborating testimonies, corroborating or refuting hypotheses, and ultimately establishing the guilt or innocence of suspects. Moreover, adherence to rigorous retrieval procedures ensures the integrity and reliability of evidence, bolstering its evidentiary value and credibility in legal proceedings. By upholding the highest standards of professionalism, ethics, and expertise, forensic scientists and law enforcement officials contribute to the pursuit of justice and the protection of society. In essence, the convergence of basic forensic chemistry principles, scientific evidence application, physical evidence types, and retrieval procedures represents the nexus of science and law enforcement, empowering investigators to confront the challenges of criminal investigations with precision, objectivity, and integrity. Through their concerted efforts, forensic practitioners play a pivotal role in unveiling the mysteries of crime, holding perpetrators accountable, and safeguarding the rights and well being of individuals and communities alike.